Well, thanks very much, everyone, for the opportunity to show you some of the results of our Lane Cove arc flash testing, and hopefully by the end of this morning you'll understand why I'm wearing this ridiculously bright orange shirt and not a suit like everyone else has been. So just before we get into some of those videos, I want to take a couple of minutes to explain a little bit about arc flash. Now, the term arc flash is a slightly inaccurate name. It comes from the early 1980s when a chap called Ralph M. Lee published an article in the US on the issue of people being burnt, entitled it The Other Electrical Hazard. Now, the early understanding was very similar to a welding flash injury in that the energy was transferred by radiant energy. So a welding arc, as small as it is, generates a large amount of radiated energy, light in all spectrums, infrared, visible, ultraviolet, X-ray, sufficient to cause flash injuries to your eyes or burns to your unprotected skin. And so their thinking was that if a welding arc could generate enough radiated energy to burn you, that an electric fault arc, because it's so much bigger, must generate so much more radiant energy, and that's what causes the burns. We now know that's not entirely correct. Although the radiant energy plays a part, the major hazard comes instead from the arc plasma, which is an unusual name, but we've known what that was in the past by the term the fireball. So in this area here that we've called the fireball before, that's arc plasma. It's at least at 5,000 degrees Celsius, and it's contact with that that causes the major injury. So what is plasma? Well, basically it's the fourth state of matter, not the fourth dimension, but the fourth state. We normally understand that matter exists in three states: solid, liquid, gas, but it also exists in a fourth state, and that's the state of plasma. Now, our sun is an example of gas that exists in a state of plasma, and the best way I can use to describe it is that it's superheated ionised gas. It has different properties to gas. If we take air, for example, air is not magnetic, although it's permeable, and it's not conductive. We use air as an insulator. But plasma is magnetic, plasma is conductive, and it's also extremely hot. As I say, at least at 5,000 degrees Celsius, and it's sufficient to cause injuries such as these. Now, these guys are actually fortunate because these ones don't include the injuries where clothing has ignited. And burns are a very, very traumatic injury, and the recovery of burns takes quite some time. So how do we protect people from that hazard? A little bit difficult here in Australia, not a great deal of guidance. We do have Australian Standard 4836, but that's for low voltage installations and equipment, so not terribly applicable to us in a utility industry. The document that does apply to us is the Energy Network Association document NENS 09, National Electricity Network Standard NENS 09. That's the document at the moment that says use 185 grams per square metre, or GSM, cotton clothing. That's why all of our workers currently wear 185 GSM clothing, because that document recommends it. Now, I'm fortunate enough to have been on the committee that's rewritten that document, and I anticipate that that will be published any time shortly, and it will no longer recommend 185 GSM cotton, but will recommend arc-rated clothing instead. But at the moment it says 185 cotton. Now, a number of people have cottoned on to the fact that cotton was not as good as what we'd previously thought, and they'd look for other advice, and they'd found it in America. America has some detailed and specific PPE standards. There's two documents that go hand in hand there. One's IEEE 1584. That's the engineer's calculation document that tries to calculate how big the boom will be if it goes kaboom. And then from that, NFPA 70E says this is the required level of PPE. This is what NFPA 70E PPE looks like. And it's rated generally, the general unit of measurement for energy is calories per square centimetre, and it's grouped into four main categories. And as we started down this arc flash PPE path, we thought, how far down this path do we need to go? Because all our guys are really busting to wear this stuff here. And we did a trial at the category 2 gear, this minimum 8 calorie, this category 2 stuff. And the feedback that came from our field trial was, Jenko, what are you trying to do? You're going to kill us in this hot, heavy gear. So we sort of said, well, what's the difference between category 1 and category 2, and how far down this path do we need to go? So we said, let's do some testing. We're fortunate enough to have the Lane Cove test station, so we said, let's blow some stuff up. Now, we had a divergence of opinion within the supply industry. Some people said, nothing wrong with cotton. Cotton served us well in the past. Let's stick with cotton. Other people said, we must go with arc-rated clothing, and it must be category 2, must be a minimum of 8 calories. We can't consider anything less. So we said, let's put both those extremes to the test. Let's compare cotton with arc-rated, and let's compare category 1 with category 2. And of course, the categories used to be called HRC, hazard risk categories. They're now changed to ARC, arc rating categories. We've also tested a number of other items of PPE. Nearly all of our PPE I've had the opportunity to blow up, so we've got quite a bit of experience at how our PPE performs. Now, unusually we didn't use the IOC or the ASTM test rig. That's based on a radiant energy model. We took the advice of Australian researcher Dr. David Sweeting, who says, look, this really doesn't represent reality because it uses opposing steel electrodes inside a Faraday cage. And how many times do we strike that in reality, an arc between opposing steel electrodes inside a Faraday cage? We don't. All of our conductors are either copper or aluminium, and they sit in parallel formation. So to better represent reality, we should use a copper electrode test rig. So that's what we did. We took Dr. Sweeting's advice. Now, my paraphrase of Dr. Sweeting's research is he's shown that a fault on parallel electrodes becomes a motor-driven plasma cannon, firing superheated ionised gas in a direction and far less of a light bomb where radiant energy is dissipated evenly in all directions. So here's our plasma cannon with Buster, our mannequin, directly in the line of fire. He's right in front of the cannon in the worst possible place he could be. Here's another view of Buster with the calorimeters, the copper disc thermocouples, attempting to measure the energy that he's exposed to. And we had a stack of cameras set up to capture the action from all different angles and also some high-speed videos. Now, this is our first high-speed video, and it shows the movement of the arc along the electrodes. Normally, we tied the fuse wire here along the end of the electrodes. This time, we tied the fuse wire to initiate the arc back here. Now, in real time, this video takes 30 milliseconds. So you can see the arc has started. It's generating plasma, superheated ionised gas, and it's moving along the electrodes. Now, if you can remember back to tech or uni, motor effect, about all I can remember from tech with my motor subjects is if you put volts on them and they spin, and Fleming's left-hand rule for the direction they turn. 3 parts of the equation: direction of current, lines of magnetic flux, direction of movement. An arc has a current, has its own magnetic field, and it moves away from the source by motor effect. There's very little damage done along the electrodes, just a few splatter marks, and now it's in plasma cannon mode, firing that superheated ionised gas in a direction. And that took 30 milliseconds in real time. So that's why you can see all the damage is done here along the end of the electrodes. Sometimes when we come along to do a post-mortem on equipment, we see where all the damage is done, and we think, I wonder what went wrong there. Well, it may not necessarily have gone wrong there. It may have gone wrong well and truly upstream. So what we found is that the energy is directional, so much so that there's 3 times the energy where we had Buster than what there is to the side. We measured the energy to the side, and lo and behold, the energy to the side lines up with that IEEE 1584 calculation document. The energy in front is 3 times that amount, but lines up with the formulas in NENZO 9. Here we graphed what we measured in front versus NENZO 9 and what we measured to the side versus 1584. So when people say to me, Darren, is 1584 correct or the formulas in NENZO 9 correct? I say they're both correct. It just depends on where you're standing. But how do you know where you're going to be? That's the trick with it. So not only did we get some good videos, but some good still images that have helped us understand the beast better. Here you can see where we have the plasma jets coming from the end of the electrodes, the molten copper droplet spray, which is omnidirectional, the plasma cloud striking the mannequin, the shirt doing its heat deflector shield trick, we'll explain a little bit more about later, and a button going flying through the air. That's one of the things we found was how easily buttons are removed, even though they're sewn on with flame retardant thread. So there needs to be some form of protection or covering for the buttons. Helmets, we've tested those, no problems with our helmets. Another one here of the shirt, immediately post the arc, once again doing its heat deflector shield trick. Plasma that's turning back into gas, so it looks like a nebula in space. Copper droplets whizzing through the air everywhere, and another one of the buttons going flying through the air. So enough about me flapping on about plasma, let's look at some stuff blowing up. Now, it didn't take us a lot of energy or a lot of time to get a reasonable amount of energy at the mannequin. You've seen this first test here, a fault current of 2 kA for an arc duration of 0.3 of a second, giving an average measured energy of 2.6 calories. That had me worried. So you can see, although the shirt appears to have survived, the mannequin has received burns to the face, and that's been the case in 3/4 of Ausgrid's historical arc flash injuries. It's been burns to the face. It's the most commonly burnt part of the body. But note that the shirt has now ignited in the centre of the chest and is continuing to burn. That's the problem with cotton, it keeps burning. With a small ignition like that, it probably would be easy to pat out. But once we crank up the energy a little bit more, that would be a little more difficult. Let's have a look at 4 kA for half a second, an average measured energy of between 10 and 11 calories. That's a lot more dramatic. and very difficult to put that out. Stop, drop and roll is very limited in its ability to put out an ignition like that. Now, if you keep watching, you'll notice that soon we'll start to see blistering on the gel coat of the fiberglass mannequin. And what we found is that I only got that when I had cotton clothing burning against it. There's not enough energy in the arc to do it, but there's certainly more than enough energy in the burning clothing to achieve that. Now, some people said, oh yes, that's because that was a knitted shirt. We'd be right because we've got the cotton drill, the weave shirt. So let's put that myth to the test. And you'll see that there is more of the shirt left initially after the arc. Same fault, 4 Ka for half a second, an average measured energy between 10 and 11 calories. So you'll see that there is more that survived the arc, but it's all now more material that's all been brought up to flashpoint and is continuing to burn on the mannequin. Now, I've had people say to me, should we have to tuck our shirts in? And I've said, well, once you get your new arc-rated clothing, it won't matter that much, but until then, you should definitely tuck your shirts in. Look what happens when the cable tie that's holding the shirt closed lets go, allows the shirt to open up, and we get the chimney effect. Now it's off and running. Now notice it's also burning up his back. So now he's far worse off than he would have been if he was naked in front of the arc. If he was naked in front of the arc, he'd only have burns on his front. Now he's got burns on his back as well. So just another one to reinforce the heat that is in burning cotton clothing. This is a knitted cotton shirt. This is a non-arc rated face shield. So just a normal mechanical impact face shield that's not arc rated. You'll see the colour chart here on the back of the head of the mannequin. We were trying to determine the temperature of the plasma by colour. You see there's very little wrap around the back of the head. But this non-arc rated face shield has survived the energy from the arc without any problems whatsoever. But you'll soon see what happens to it from the heat from burning clothing. It's totally destroyed. There is so much more energy in burning clothing than what there is in the arc. So up until the point that our cotton clothing ignites, it provides protection. Once it ignites, it makes the injury worse by increasing the depth of the burn and the area of the body that's burnt. Let's compare that with arc-rated clothing. So this is the category 2 stuff, the thicker, heavier stuff. Same test, 4 Ka for half a second. As you can see, it's a dramatically different result. Self-extinguishing is probably the best way to describe that clothing. It doesn't continue to burn, so it doesn't exacerbate the injury. Let's have a look then at the category 1 stuff, the supposedly unsafe category 1 because it doesn't meet the minimum 8 calorie mark. What we found is the result was very, very similar. So what we found was that the difference between cotton and arc-rated clothing was enormous. The difference between category 1 and category 2 was marginal. Very little difference in terms of actual protection. Let's have a look then at some of the high-speed cameras to see what's going on inside that fireball, inside that blinding flash that's too bright and too fast for our eyes to see. This is a high-speed camera with filters put in front of it like a welding visor to see what's going on inside the fireball. This takes the half a second test out to about 70 seconds. So you can see how much the face is copying. The speed with which this arc moves is just phenomenal. This is all taking place inside half a second. To the naked eye, he's engulfed in the fireball. Now, at first you start to see some flames coming off the reflective strip and you go, ah, that was the problem with that polo shirt. It was the reflective strip. But the reflective strip's actually doing a good thing there. It's doing a job called ablating, which is a job similar to heat deflector shields on spacecraft during re-entry. You know, you watch the movies and you see the spacecraft re-entering and there's all the flames coming off the front. Well, that's what this is doing. It's burning off the outer layer but protecting what's behind. Now, the cotton itself, there's very little flame coming from that. That's because it's absorbing the energy and being destroyed by it. Now, we saw what happened with the Space Shuttle Columbia when it came in for re-entry with missing heat shields. It absorbed the energy and was destroyed by it, and that's what's happening with the cotton clothing. You see it's now burst open. both above and below the reflective strip. And if we watch the video immediately post the arc, you'll see that the reflective strip and the cotton behind the reflective strip is untouched. So that flame up during the arc is actually a good thing. And that's really what the arc-rated clothing looks like during the arc. So this is our arc-rated clothing. Same test, the half-second tests. Once again, you can see how much the face is exposed. So real evidence of the need for a face shield, some form of protection for the face. And you'll start to see a lot of orange flame coming off this shirt now, as it does that heat deflector shield trick. Now, although this is only a half-second test and we're not even halfway through it yet, you'll see that the buttons are off already. They're sewn on with flame-retardant thread, but it's only flame-retardant threads, not fireproof thread. And because the button holds a few threads proud, they're very easily burnt through. The buttons are off, and that allows the shirt to open up. So the shirts that Ausgrid are getting will come with a covering, a placket covering the buttons to prevent that from happening. You get a bit of an idea of the speed of it by the speed of the copper droplets coming off the electrodes. And then, of course, immediately post the arc, it takes about 0.2 of a second for the clothing to self-extinguish, for it to go out. I did have someone say to me, "What's in that smoke? There could be all sorts of nasties in that smoke." I said, "Did you not just see the few previous videos?" Now, this arc-rated clothing comes in both woven form and knitted form, so just this diagram explains the difference between weave and knit. Now, if you lose one strand in a weave, it doesn't make much difference, but if you lose one strand in a knit, which loops in and out of itself, it opens up. So when we had a look at this, we found, oh, look, this stuff's available in a knitted form, which is lighter and cooler, more comfortable, and it actually comes with a higher rating. But once we hit it with our plasma cannon, we blew holes in it everywhere. So even at its ATPV, there were holes blown in it everywhere. That's why Nenzo 9, when it comes out, will not recommend knitted form, but will recommend woven form because of this result with the knitted tests. Now, there's two forms of arc-rated clothing, generally grouped into two main types, inherent or treated. That's often, you'll hear those two terms used. This one is inherent, so the flame retardancy is inherent in the fibres themselves that it's knitted with. The treated are cotton or cotton nylon blends treated with a flame retardant chemical. Now, it normally goes by the brand name Proban. That's because the real chemical name is tetracus hydroxymethylphosphonium chloride, which is why they use Proban. But it sits inside the cellulose fibre of the cotton, and when it's exposed to heat, it gives off an inert gas that prevents that cotton from burning, and that's how it works. Now, the inherent salesman will tell you that the treatment all washes out. The treated salesman will tell you that none of it washes out. We did one test, so I'm loath to draw too many conclusions from a single test, but we had one test with an old, faded, treated shirt. And what we found was that there was some level of deterioration. So it didn't perform quite as well as a new shirt, but it was still flame retardant. It still went out. It didn't keep burning. So even though it was old and faded, it still retained that flame retardancy. So some level of deterioration, but still a heck of a lot better than untreated cotton. Now, I mentioned the face shields. I've been testing out face shields because I figure if I'm going to ask people to wear it, I need to know what it's like to wear myself. So much to the disgust of my wife and the amusement of my neighbours, I've actually been testing out face shields as I've been doing mowing and whippersnipping at home, because I figure that's the hardest that I work physically these days, is doing the mowing and whippersnipping. So I think the neighbours think I've got a minefield in my front yard, but this one here without the chin cup, that's been my favourite from the mowing and whippersnipping trial, because it's the lightest, the coolest, the most comfortable, and allows it to breathe. Now, I'd heard people say it must have a chin cup, the face shield must have a chin cup. I was really quite the sceptic to that, because I'm thinking, well, we're going to go from safety glasses to a face shield. Surely that's a big improvement, till I did the tests. This first one is the face shield with the chin cup, if the mouse will come back to me. This is immediately after the arc, and you'll see that although there's some heat up here, that the chin cup is doing the job that it should. And as the flame comes up the shirt, you'll see that the chin cup does the job it should in preventing the flame from getting up under the visor. And that's in stark contrast to the one without the chin cup. This is not reflection. This is all up inside the visor. So my favourite was a late scratching. So the chin cup is essential, it is important. Undergarments, haven't got cotton outer garments to burn so readily. I thought, oh, now we might be up for FR undergarments. But what we found was that I had trouble getting cotton undergarments to burn. I was actually trying to get cotton undergarments to burn without any real success. You'll see this one here. We burn the front of the shirt, clear off the mannequin, exposing the cotton singlet underneath. This is a man after my own heart. Got no hair, orange shirt and a cotton singlet on. And I was expecting to see the cotton singlet on fire at this stage, and that's not what we got. A couple of reasons for that. I think if you see this here, you'll see that by the time the arc-rated shirt is gone, that the front of the cotton singlet is all charred, it's carbonised. So on the front surface has carbon, on the back surface has the torso. So there's very little oxygen getting to uncharred cotton. So although there may be some risk, it would appear to be a low risk. Wool is excellent. Wool is naturally flame retardant. You'll hear me use the two terms flame retardant and arc-rated. Flame retardant is tested for a flame, but it may not necessarily have been tested against an arc to get a calorie rating. So this woolen t-shirt hasn't been tested to get a calorie rating, so it's not arc-rated. So not all flame retardant fabrics are arc-rated, but all arc-rated fabrics are flame retardant. So wool is excellent. Synthetics are out. Synthetic continues to melt, burn and drip against the skin. No good at all, and that applies whether it's male or female. This was an interesting experience, walking into bras and things, trying to explain why you're going to use an Ausgrid credit card to buy bras, and then explain to the boss why you've been buying bras and an Ausgrid credit card to blow them up. So, but we have more females in our employees now, so that our recommendation of less than 10% synthetics applies, regardless of whether it's male or female employees. Wool's excellent. You can see woolen jumper, no problems at all. Once again, it hasn't been arc tested, so it doesn't have a calorie rating, but it's flame retardant. This one we compared a 40 calorie switching jacket with a woolen furnace coat, non-arc rated, and you can see that the woolen furnace coat outperformed the 40 calorie switching jacket. Leather outers do a great job. Although our leather outers over our insulating gloves, although they don't come with an arc rating, leather provides a really good thermal barrier. There are other types that people are looking at as possible protective outers, but leather provides a great thermal barrier for our gloves. Wet weather gear, once again, the non-FR versus the FR. If it's FR or flame retardant, it should be compliant with 14116. FR can be a very loosely applied label. Look for 14116. The FR stuff's good. Asbestos, once again, the non-FR and the disposable overalls no good. They continue to burn, melt and drip. The FR ones are good. And with some of our other asbestos stuff, there's been some different results that we've got. Most of it's not too bad. Shields or barriers. This was what we call our jousting shield, a 600mm Lexan shield, and you'll see that it does a very good job at preventing the plasma from reaching the individual. So what we're looking at is where we can use that concept now. Where can we put the barrier in between the individual and the arc, rather than trying to put the barrier on the individual in the form of a bomb suit? That goes on ad nauseum, and it's quite effective. So what we found is that the benefits from arc-rated clothing, category 1 or 2, my own personal belief is one of the reasons we don't have more people in Australia in arc-rated clothing is our previous belief that it must be category 2, and we've tried to put people in clothing that's too hot and too thick. A face shield and some form of shield or barrier. Look for a risk assessment. Don't just rely on estimated instant energy. Do the risk assessment. Take those other factors into account. What's the task you're doing? What's the condition of the equipment you're working on? And bow tie diagrams can be useful for that. So that's my time up.
Brilliant. So, thank you very much. Now we do have a few moments for questions for Darren.
This is category 1. Yep.
Can we have Kev, can we just have the microphone, because the guy's listening.
I just asked what category the shirt was.
Yeah, the question was what category shirt is it? This is category 197 GSM. So our guys are currently wearing 185. This is 197. The category 2 stuff is 238, 240 GSM. So a dramatic increase in weight and heat. This is 197.
The typical questions to answer that would be great if you could provide some comment on is how many instances of arc flash that you can point to as examples, and then obviously the cost, incremental cost for like the Arc 1 type.
Yes, it is, no doubt, arc-rated clothing.
Just not talk a business case.
You're having discussions with other people.
Yeah, no doubt, this clothing is more expensive than your normal cotton clothing, but Ausgrid alone has had a number of arc flash incidents, and a couple whereby we've had ignition of cotton clothing that has caused dramatic burns. So they are a low frequency but a high consequence event. Yeah.
Darren, Chris Halliday, Power Logic.
Hello, Chris.
You know the question. NANS 09, when?
When? Hopefully very, very soon. I know I have. I don't have a great deal of control over its actual publication. I hope that it will be very, very shortly.
Yeah. David.
You're alluding to the merit of...
I'll just get you to wait to the microphone there, Dave. Thanks.
You're alluding to the merit of the woolen garments being well resistant to flame. At Nundle, at the wool mill, they do a very fine woven shirt. Expensive,
yep,
but very fine, and it claimed to be no hotter, no cooler.
Yep.
I wondered if you'd ever had a chance to consider that prospect.
We had tested things like that woolen undershirt, so the superfine merino woolen undershirts. Because they tend to be in knitted form, the t-shirt type material, it tends to blow apart like the knitted arc-rated material. But there's some other woolen stuff that we haven't tested. Bluey jackets, like the spun wool Felton bluey jackets that some of us have, they've tested well, but I haven't tested clothing like that, David, no. So.
We were waiting for a query comment.
Oh, yeah, sure. Alex again.
Darren, very interesting work, and great to see that you've got David Sweeting involved. When we were revising 2067, one of the objectives was to address both earthing and arc flash, but we haven't proceeded with the arc flash side of it because all this testing work's underway. But I was wondering whether from all the testing that's been done, has there been any conclusions from a substation or switchgear or substation installation design point of view that any conclusions have been drawn?
I guess we haven't been looking so much at that from a switchgear design perspective, but perhaps more so in our risk assessment. So if we take, for example, as we're looking at some of our different types of switchgear, in our risk assessment, a very, very rough bow tie or threat barrier diagram, switchgear A having mechanical interlocks and internal arc classified, so things to prevent the arc, but also engineering controls should it occur. Another type of switchgear without any of those engineering controls, whereby we are looking to use higher rated PPE, so some of that switching jacket, face shield sort of stuff for those. But we haven't been looking at, as far as from a switchgear design, been mainly from the PPE perspective that we've been looking at tests.
Jeff here had a question, and then you, Bob, if that's okay. Jeff first, if you wouldn't mind. Yeah.
Interesting work you've been doing, and sort of quite relevant to what's been happening in New Zealand recently. We've, just to give sort of more a comment than a question, but in New Zealand we obviously don't have the temperature issue, and we don't have guys concerned about the heat of working, but we've generally standardised on a Category 2 arc-rated PPE, and that's been the case for a number of years now. But a lot of it's also around, as you correctly identified, what is the risk there, what is the incident energy, and it's about selecting the right PPE for the occasion. And whilst we've standardised on 2, we also have a situation where there has to be a level 3 or level 4 switching jacket, the full bomb suit effectively, because of the arc risk, and trying to engineer it out where we can. Your comment about the face shields, we've standardised, our guys have standardised now on wearing a balaclava underneath as well to get away from that risk of if something comes up and under the shield, to have the balaclava there as another layer, so almost like having the undergarments.
Yep.
Have you looked at that at all? Or?
Yeah, we have, and what we've found is if the face shield with a reasonable chin cup is good, and some of your switching jackets have really high collars that will come up underneath the chin and provide fairly good protection. And once again, with the heat issues that we have in Australia, I think that's one of the things that we need to take into account is what we're asking our people to wear in what can be hot climates in part of our country, is that, you've got to take that into account. So we're not looking at the balaclava from an Ausgrid perspective at the moment.
Okay,
yep.
Cool.
Well, we might make yours the last one.
Bob Parkinson,
Hello, Bob.
Darren. I really appreciate your work because that needed to be finished. There's a lot of research being done, and there's a lot of information that had never been tied together and something implemented. So congratulations. But the real challenge is going to be the cultural issue, is it not?
Yes, and a part of what I've been doing is running around Ausgrid showing these videos, and not only with Ausgrid, I've been very fortunate, I suppose, over the last 12 months or so to have gallivanted around the countryside, showing a number of different utilities these videos. and sharing that information. So it is a change that is growing, and most of the time when I show people that evidence as to why we're going that way, Bob, rather than just saying, here's your new clothing, you have to wear it, but giving people the reasons why, then you get a reluctant acceptance, I suppose, as to the reasoning behind it.
Are you drawing correlation between this and high voltage equipment as well? Because I think one of the incidents that I was involved in where a person came in close proximity of 33 kV, he was blown clear. And the injuries were bones and things like that. But the burns came from synthetic underwear. He had cotton clothing on, and the burns were on his stomach where the cotton T-shirt had melted. There was no face issue or anything like that.
Yep.
So I think you need to be conscious that certain circumstances to encumber them with all this will get resistance.
Yes, no doubt about it, absolutely. And that's why we're trying to balance that level of protection as far as how far do you go with bomb suits and balaclavas and things like that. So what is something that is hopefully reasonably practicable. Hence my mowing and whippersnipping trial, so that I get a bit of an understanding as to what it is that we're asking people to wear.
I did say that was going to be the last question, but I presume that plenty of people do have further questions for Darren, that you are available for a little while.
Absolutely, yeah.
And Darren again has conveniently put on the brightest clothing, so I'm sure we'll be able to find him to ask those questions. So I might just round out, Darren, and say that within New South Wales we have made a decision right across all three organisations to adopt this clothing in a stage form over the next 18 months. And that's not just for our own employees, that's all contractors and ASPs that work on our network as well will be mandated to wear the clothing via safety rules within the coming 18 months. And so we're going through a program of advising our staff and contractors of that decision. In fact, many have adopted already. Ausgrid are well and truly down the path, and their staff will be in it from very early next year. Many of the ASPs have as well. And so, again, sort of on behalf of the industry, Darren, I really thank you for your efforts. Thank you very much.